Hello students, in this section we will discuss homogeneous linear equations. As we know that the matrix form of general linear equations is like this: capital AX is equal to B, where capital A is the coefficient matrix, X is a variable vector and capital B is the column vector having some constants, some numbers. For homogeneous equation, we know B is equal to 0, that is the right hand side is equal to 0. Therefore the equation takes the form Ax is equal to 0. And so in this case we see that rank of augmented matrix AB is equal to rank of augmented matrix A0, and we know that if we omit certain column or row, certain 0 column or 0 row from a matrix, then the rank do not change. Therefore, if we omit this 0 column, then the rank of this matrix does not change. So the rank of A0 will be equal to the rank of the matrix obtained by omitting this column 0, and that is matrix A. So that is rank of A, and so this is the condition of consistency. Therefore we see that homogeneous linear equations are always consistent. Consistent means they always have solution. So they always have solution, and it can be easily seen from the equation that capital X equal to 0 satisfy this equation. So capital X equal to 0 is always a solution of this homogeneous linear equation. Numerically, if we take some equation like this, x plus y equal to 0 and x minus y equal to 0, then we see that x equal to 0, y equal to 0 satisfies these two equations simultaneously. So it is a solution of these equations, and and this is called zero solution. So we see that every homogeneous linear equation always has zero solution, or we call this solution trivial solution. So this shows the consistency of homogeneous linear equation, that homogeneous linear equation always has zero solution. But now you see, as we have discussed in last chapter of non-homogeneous linear equation, that if the equations are consistent, then there may be two conditions with the equation. The first one is whether they may have unique solution. The first condition is unique solution. The second condition is for infinite solution. Now, what is the meaning of unique solution? Means the equation has only one solution. Now, in case of homogeneous linear equation, we have seen that 0 is always a solution of homogeneous equation. So if the equation has unique solution, then that solution will be zero solution. So unique solution or only one solution, or we may say zero solution, because 0 is always a solution. So in case of uniqueness, 0 will be the only solution of homogeneous linear equation. And this case occurs when this rank of AB equal to rank of A is equal to number of unknowns. What is the condition of unique solution? The condition of unique solution is rank of A is equal to n. N means number of variable or unknowns. Therefore, if rank of A is equal to number of unknowns, then our equation has only 0 solution. In second case, the equation has infinite solution. Infinite solution means the equations has non-zero solution. Except the 0 solution, they have non-zero solutions. So in this case, non-zero solution exists. And you know the condition of infinite solution? The condition is rank of A is not equal to n. N means number of unknowns. So therefore, in short, when we solve homogeneous linear equations, then there are two cases. One is whether it has only 0 solution, that is only trivial solution, or it has non-zero solution or non-trivial solution. So to find it, we just find the rank of the coefficient matrix A, and if this rank is equal to number of unknowns, then the equation system has only 0 solution. And if this rank of A is not equal to number of unknowns, then the system of equations have non-zero solutions. Now let us take an example, and by the example we will understand it more clearly. Therefore, what is the procedure to handle the homogeneous linear equation? First find the rank of the coefficient matrix A. If rank of A is equal to number of unknowns or number of variables, then the homogeneous equations has only 0 solution, that is trivial solution. If rank of A is not equal to number of unknowns, then Ax equal to 0 has non-zero solutions, that is non-trivial solution. Now remember one thing, 0 is always the solution. 0 is also the solution in the case when it has non-zero solution. So now let us have an example. The example is example 1. X plus 2y plus 3z equal to 0, 3x plus 4y plus 4z equal to 0, 7x plus 10y plus 12z is equal to 0. So whose coefficient matrix? So the coefficient matrix is solution. The coefficient matrix is, yes, capital A, and the matrix is 1 2 3 1 2 3 3 4 4 7 10 12. Now we reduce this matrix in echelon form by our usual procedure, for which we apply the operation R2 minus 3R1 implies R2, R3 minus 7R1 implies R3. Then it reduces to 1 0 0 2 3, here minus 2 minus 5, and here minus 4, and this is minus 9. So applying these operations we get this matrix. Now again we have to reduce this element to be 0 using this element. So apply R3 minus 2 R2 implies R3. We get this is 1 2 3 0 minus 2 minus 5 0 0, and this is equal to 1. Therefore, now this is the required echelon form. Echelon form, and so rank of A is equal to the number of non-zero row in echelon form, and there are 3 non-zero row, so rank of A is equal to 3. Now rank of A equal to 3, and we see that there are 3 unknowns in our system of homogeneous equations x, y and z. So this 3 and the number of unknowns is also 3. Therefore rank of A is equal to number of unknowns, and so this is the case when the equation has only 0 solution. Only 0 solution. You can see it. You can see here or you can see here. Therefore, so the system of equations has only 0 solution. Let us take another example. X plus 3y minus 2z is equal to 0. 2x minus y plus 4z equal to 0. X minus 11y plus 14z is equal to 0. So these are the homogeneous linear equations, a system of linear equation. Now we have to check whether this system has only 0 solution or it has non-zero solution. So for which we just find the coefficient matrix. The coefficient matrix is capital A 1 3 minus 2 2 minus 1 4 1 minus 11 14. Now we reduce it into the echelon form to find the rank of this matrix A. So for which we just reduce this and this element to be 0 using this element. Now for which we apply the operation R2 minus 2R1 implies R2, and R3 minus R1 implies R3. Therefore it reduced to 1 3 minus 2, this is 0, this is 0, minus 7, and this is 8, minus 14, and this is 16. Now again using this element, you reduce this element to be 0, for which you apply the operation R3 minus 2R2 implies R3, and thus this matrix reduced to 1 3 minus 2 0 minus 7 8 0 0 and 0. Therefore now it is the required echelon form, and so the rank of A is equal to the number of non-zero row in the echelon form. There are 2 non-zero row, so its rank of A is equal to, so its rank of A is equal to 2. Now you see that the rank of A is equal to 2 while there are 3 variables x, y and z, so it is not equal to number of unknowns, which are 3. So you see that this equation has, so these equations have non-trivial solutions or non-zero solutions. Now we have to find all those solutions. For we write down the reduced equations. The reduced equations are, what are the reduced equations? It is your echelon form. So just write down the equations by using them. This is a coefficient matrix. Now we have the reduced equation 1x plus 3y minus 2z, x plus 3y minus 2z is equal to 0, and the second is 0x minus 7y plus 8z, minus, that is minus 7y plus 8z is equal to 0. Right hand side is always taken to 0 because we are working on homogeneous equation, so right hand sides are always 0. So therefore we write down the reduced equation by the reduced echelon form. Now we see that we have two equations and three variable. You have variable is equal to 3 and equations are 2. So exceeds number of variable is equal to 1. So we take one variable to be constant. 4. We take z is equal to c. Then this implies we find y by the second equation. Y is equal to 8 by 7c. Now we put these values of y and z in this equation and we find x, so that x is equal to minus 3y. Minus 3y means minus 24 upon 7c plus 2z. 2z means plus 2c, and that is equal to minus 10 upon 7c. So we find the solution of these equation. The solution is x is equal to minus 10 upon 7c, y is equal to 8 upon 7c, and z is equal to c. Now where c is the arbitrary constant, for different values of c we get different solution of our homogeneous linear equations. But here we also observe that if we take c equal to 0, then x equal to 0, y equal to 0, z equal to 0. So 0 is also a solution of these given homogeneous linear equation. But except zeros, we have certain non-zero solution too. For example, if we put c equal to 1, we get one of the non-zero solution. If we put c equal to any other value, non-zero value, then we get a number of non-zero solution of these given equation. Let us take another important example. Find the real values of lambda for which the following equations have non-zero solution. The equations are x plus 2y plus 3z is equal to lambda x, 3x plus y plus 2z is equal to lambda y, and 2x plus 3y plus z is equal to lambda z. Here you see in right hand side, you also have the variable terms. So we take these terms in left hand side, and what happened then? The equation becomes, please take it in left hand side, you get 1 minus lambda x plus 2y plus 3z is equal to 0. The second is 3x plus 1 minus lambda y plus 2z is equal to 0. 2x plus 3y plus 1 minus lambda z is equal to 0. So therefore the equation reduced to this form, and these are homogeneous linear equation. Now the question is that we have to find those values of lambda for which these equations have non-zero solution. Now the condition of non-zero solution is that the coefficient matrix rank, now first find the coefficient matrix A with whose coefficient matrix is matrix A. Matrix A is 1 minus lambda 2 3 3 1 minus lambda 2 2 3 1 minus lambda. Now the condition is we have to find those values of lambda for which these equations has non-zero solution. Now what is the condition of non-zero solution? That rank of A should not be equal to number of unknowns. This is the condition. What is the number of unknown? That is the 3. Number of unknowns are 3, x, y, z. So rank of A should not be equal to 3. Now you see A is a 3 by 3 matrix. So its rank may be 3, 2 or 1. But we have been restricted ourselves that rank of A is not equal to 3. So if the rank of this matrix is not equal to 3, then it has no minor of 3 order which is non-zero. So the minor of order 3 should be equal to 0, and this implies minor of order 3 should be equal to 0. Minor of order 3 means determinant of order 3 should be equal to 0. If it is not, if the determinant is not equal to 0, then its rank will be 3, and if the rank will be 3, then it will have 0, only 0 solution. This is not the condition of non-zero solution. So minor of order 3 should be 0. There is only one minor, and that is the determinant of A itself. So this implies determinant of A should be equal to 0. Now determinant of A means 1 minus lambda 2 3 3 1 minus lambda 2 2 3 1 minus lambda is equal to 0. Now we find the value of this determinant. Now using C1 plus C2 plus R1 plus R2 plus R3 implies R1, we get determinant 1 minus lambda plus 3 plus 2, that is 6 minus lambda, that is also 6 minus lambda, that is also 6 minus lambda, this is 3, this is 1 minus lambda, 2 2 3 1 minus lambda, that is equal to 0. Now take 6 minus lambda common from first row, you get 6 minus lambda, determinant 1 1 1 3 1 minus lambda 2 2 3 1 minus lambda is equal to 0. Directly find this determinant, or again apply column transformation. C2 minus C1 implies C2, and C3 minus C1 implies C3. Then it becomes then it becomes 6 minus lambda, and this determinant 1 minus 1 1 3 2, this becomes 0 and 0. Now this minus this, therefore this minus this, that is minus this minus this, 2 minus lambda, and this is minus 1, this minus this, plus 1, and this minus this, minus this minus this, this minus this, again minus 1 minus lambda is equal to 0, and this become 6 minus lambda, and this is minus minus plus 2 plus lambda, 1 plus lambda plus 1 is equal to 0. This becomes 6 minus lambda, this is lambda square plus 3 lambda plus 3 is equal to 0, and this implies 6 minus lambda equal to 0, that is lambda is equal to 6, and lambda square plus 3 lambda plus 3 is equal to 0. Now you see that this equation gives a imaginary value. So lambda equal to 6 is the only real value for which the given system of linear equations have non-zero solution. So the only real values is lambda equal to 6. So lambda equal to 6 is the only real value. So that's all from the homogeneous linear equation, and we have discussed homogeneous linear equation. Just find the coefficient matrix capital A for the homogeneous linear equation, find its rank. If the rank is equal to number of unknowns, that is the number of variables in your equation, then it has unique solution, that is only zero solution. And if the rank of A is not equal to the number of unknowns, then it has non-zero solution, that is non-trivial solution. Thank you.